Hello everybody. So today I will talk about the system design of WhatsApp. Okay. So yesterday I did the deep dive of this topic. So this one. Partition Redis popped up by chat versus by user. And I will do this topic again for my own practice sake. So yesterday I quite struggled to explain about this topic. So yeah, I will try to be more precise and more, concise today. Okay, so I will talk about this part in the system. Redis pops up. So as a quick review, in the messaging service, we use WebSocket connection. So users are connected to real-time message service server through WebSocket. But because there are so many users in a service, this real-time message service is scaled out. So it is possible that we have to send the user's message from one server to the user who is connected to another server. So for that, we use the Redis PubSub as a kind of intermediate queue. So this Redis PubSub publishes a message to the servers who are interested in that message. Interested in means that if there's a user who has to receive that message, that server subscribes the queue and Redis PubSub publishes a message to the servers which registers. Yeah. So that's how this part works in the system. That being said, I will talk about the topic discussion. So I can make this topic per chat ID or make this topic per user ID, and I will compare this. So in this video, I will think about two extreme cases. So number one, there exist only one-on-one chat rooms in the app, but each user has so many chats. This means that chat room is very small, but there are so many chat rooms. And also I will think of another extreme case where there are 100 people in one chat room, but each user belongs to only one chat. This is a case when the chat room is very big, but the number of chat rooms is small. Okay. Okay, so I will talk about this one, the first one. And I cleaned up the architecture a little bit so that we can focus on this part. And also I separated the sender servers and receiver servers. Of course, in reality, this real-time message service server does the sender role and also receiver role. But for now, in this video, for the clarity, I separated this. Okay, so let's think of the part chat ID basis case. So the message is, okay, let's say user 1 is connected to this sender server and user 2 is connected to this receiver server. And these two users are in the same chat. In this case, when the user 1 sends a message, the sender 1 server sends a message to the topic which corresponds to the chat. And because there is only one other user in this chat room, who is user 2, this message is published into this server, who is connected to user 2. Okay, this way. Yeah. So this is what happens. Good. And I will talk about the second case. One topic per one receiver user ID. So in this case, the message from user 1 is sent to the topic for the, which works as a kind of delivery box for user 2. And then that topic sends a message to the receiver server, which user 2 is connected. Yeah. So far, these two options work in the same way, but the difference is that because user 2, user 2 has 100 chat, this server has to subscribe 100 topics for this user 2 only. So the number of subscriptions from this server is 100 times more. And of course, the number of topics in the Redis PubSub is 100 times more in the second option. And that being said, actually, the biggest issue is the latter one, Redis memory usage for the 100 times more topics. So, yeah, because there are 100 times more topics in the second option, of course, the memory usage to manage the subscriptions becomes 100 times. Because we're building the system for so many users, this 100 times of memory usage is a big pain. So I use the first option. No, what did I say? Maybe I said wrong. So if I choose par chat ID, it becomes 100 times more subscriptions. So I will go with the par user ID basis. Yeah. And the reason why the number of subscriptions from, the problems that this server has to have 100 times more subscriptions for this user too, why this doesn't become a big issue. It's because, let's say there are n servers here, and there are m star Redis clusters here. Sorry, Redis instances here. So in this case, the number of connections which is created between these two components is n times m. So even if this server, let's say the user 2, this server subscribes topic. Oh, wait. So I will write it down. So let's say there are two servers. There is a server, and this user 2 and user 3 are connected. And let's say there is a topic, which is a instance 1 and instance 2 of the Redis cluster exists here. Oh no, actually this instance 1 is enough. So let's say for this user 2, this subscribes some topic. Yeah, I think this is easy to understand. Okay, so in this case, even though there is a subscription, okay, there is 2 subscriptions from this server to this instance. Actually, there is only one connection between. One kind of TCP connection which is kept alive. So there duplexed on the same connection. So that's why I said there are only n times m TCP connection arrive between these two components. So the number of subscriptions doesn't become an issue as long as the number of physical servers count is limited. So I can think of this as a kind of just a logical namespace. I mean, the, subscription is a kind of subscription issue is a kind of, what should I say? The subscription between this and this is the difference of the kind of namespace, logical namespace. And physically, it doesn't become the bottleneck. Okay. So now I've talked about scenario number 1. Okay, so for scenario number 2, 100 people in a chat room and each user has only one chat. So I will talk about the option 1 first. So in this case, when the user, so there's so many users, user 3, user 4, something like that. And I make them separate so that I can easy to explain. So in this case, in the first case, when user 1 sends a message, this sender server sends a message to the topic which corresponds to the chat. And because there are 99 other users in the same chat room, there are up to 99 servers who are subscribing. Because of the reason I said just now, if there are if there are multiple users who are in the same, receiver server, they share the same connection. But that being said, let's say 99 users are, distributed across 30 servers. In that case, this Redis PubSub has to send to 30 servers. So that's what happens with the first option, topic per chat. And when I think of the second option, topic per user ID, what happens is that when user sends a message to user 1 sends a message, this server has to send the message to 99 topics exactly, because there are 99 other users. So in this case, this server has to send messages to 99 topics. And of course, as I said, maybe there are multiple topics who are in the same instance. In that case, they can share the same. They share the same connection. Oh no, wait. It's actually not true because how should I say? Yeah, connection is shared. Yeah, I can say. Yeah, sorry. So as long as some users, some topics are in the server, they share the same connection. So this funnel probably doesn't have to send to 99 instances. But even that being said, let's assume that there are 30 instances. 99 topics are distributed across 30 servers. In that case, this sender server has to publish to 30 instances. So that's what happens. And after that, each message is sent to exactly one subscriber. Because this is per user ID basis. Yeah. So each server subscribes exactly one topic for that user, for the connected each user. So in this case, sender does the fan out, and then that message is published into exactly one receiver server. Okay. So I will compare these options again. So in the first case, what happened is that this sender server has to publish to only one topic, but that message is fan out to multiple servers, receiver servers. So that's what happened with option 1. And for option 2, the sender has to publish the message to multiple topics. And then that message, each of those messages are sent to exactly one receiver server. So in the first option, Redis PubSub does the fan out. And also the number of messages in the Redis PubSub is equal to the the number of messages in the Redis PubSub is equal to the original number of messages sent by user. But in the case of second option, this sender server does the fan out, and the number of messages in the Redis PubSub is 99 times, or I should say number of Redis PubSub instances which has a topic for user who are in the same chat. Okay, so comparing these two options, I will go with the first option. One topic per one chat ID. There are two reasons. So number one, fan out in the Redis PubSub is more scalable than fan out in the sender server. So to be honest, I'm not super clear why it is, but Redis PubSub is an on-memory database, so it is more easily scalable. But it comes from the reason, it comes from the low layer reasons. So maybe I will take some videos or follow-up someday. But my quick understanding is fan out. Redis PubSub is better at fan out compared with this sender server. And obviously, the second reason is the messages are not fan out in the Redis. We don't have to put duplicated messages in the Redis PubSub. So memory usage in the Redis PubSub in the first option is less than the second option. So that being said, I choose topic per chat ID. Okay, so now I compare these, two, options. Okay, so now I will quickly review today's content discussion. So in the first scenario, I chose the topic per user ID option. It was because of the reason from the Redis PubSub memory usage. So in either case, it was the same that one sender server sends a message to exactly one topic, and that message is published into exactly one receiver server. It was the same for two options. However, because each user has 100 topics, this receiver server has to subscribe 100 topics for this one user in case of chat ID based topic option. So in that case, number of subscriptions managed in the Redis PubSub becomes 100 times, and it uses more memory usage. So I use the second option, per user ID option. Okay, and for the second scenario, sorry. So for the second scenario, the problem was, yeah, I remember. So if I choose the chat ID basis option, this sender has to send to exactly one chat ID based topic, but that message has to publish to all the 99 users who are subscribing it. So Redis PubSub does the fan out, which is okay. But if I choose the second option, this sender has to publish the message to 99 topics, who is for other users, 99 other users in the same chat room. And then the message is sent to exactly one user, receiver, because now the message is, topic is per receiver user ID basis. And as I said, Redis PubSub is better at fan out of the messages. I chose the first option. Okay. Oh, and of course, as I said, the number of messages, because, if the sender server does the fan out here, the number of messages in the Redis PubSub is more than the number of original messages. So in that perspective, the chat ID based topic is also better. Okay, that being said, I finished my today system design practice. Thank you so much. Bye.